And welcome to section 4.5, the final section of chapter 4 in studying logarithms. And as you can see by the title, we're going to be using logs to solve some pretty difficult equations. Some of these get pretty tricky, so I'm going to show you how to do them. Here we go. 3 to the x equals 8. 3 to what power equals 8? Now, I'm going to show you how to do this because it's really clever. To get an exponent, to get a variable or an unknown out of the exponent, you take the log of both sides of the equation. Now, because I'm a mathematician, I'm going to use natural logs just because I like them better, but you can use logs or natural logs and it doesn't matter. So I'm going to take the natural log of both sides. And here's the thing, when you take a log or a natural log, the entire side of the equation goes into the natural log. Now, what I can do now is, by doing this, I can now use the rule where the x comes down. So this is equal to x times the natural log of 3. Okay? Hopefully you remember that from section, I think, 4.3. And now you can divide by the natural log of 3 on both sides. And so we get x equals the natural log of 8 divided by the natural log of 3. Does that seem kind of familiar to you? What does that kind of remind you of? It's the change of base formula. Because if you think about it, this is 3 to the what equals 8. Or if we wrote it as just a straight log, it would be log base 3 and 8. And remember how in the last section we did change of base formula. The log of this divided by the log of this, or the natural log of this divided by the natural log of this. And look, it comes right out of the formula. So this is kind of an indirect proof of the change of base formula that we learned in the last video. Anyway, let's grab our calculator and do the natural log of 8, which is approximately 2.079 divided by the natural log of 3, 1.0986. And now we just divide them. So hopefully you can see that this is kind of the change of base formula that we're using, 1.0986. So you get an answer of approximately 1.892. All right, so same thing on this one. 5 to the x equals 28. By taking the natural log of both sides, we're going to see the change of base formula fall out. So ln of 5x equals ln of 28. X comes out in front. And divide both sides by the ln of 5. So natural log of 28 divided by the natural log of 5. 3.3322 all over 1.609. So x is approximately equal to 3.3322 divided by 1.609. So approximately 2.071. And that's if you round to the thousandths place. Okay, so those are pretty straightforward. What happens if they start to get a little tougher? So here we've got 5 to the x minus 3 is equal to 3 to the 2x. Now, this is almost a calculus level difficulty question. This one is pretty hard. We're trying to find an x value that will make, or maybe all of the x values that make this equation true on both sides. And we notice that these two aren't the same. If this was 3 and 3, we just set the exponents equal to each other like we did earlier. But we can't do that here because it's 5 and 3. So let me show you how to walk through this. Start by taking the log or the natural log of both sides of the equation. Okay? Natural log of 5 to the x minus 3 equals natural log of 3 to the 2x. Now that we've done that, we can bring our exponents down in front. Now, remember how x minus 3 is in parentheses? It needs to stay in parentheses when you bring it down here. Okay, don't drop these parentheses because then it's just negative 3 times this, but the x also needs to times this. Here we've got 2x natural log of 3. Now I'm being a little sloppy maybe by not putting these parentheses in, so if you're having difficulty, maybe you should do that. So now let's do the distributive property. So I have x times the natural log of 5 minus 3 times the natural log of 5 equals 2x natural log of 3. Now remember, natural log of 5 and natural log of 3, those are numbers I'm going to find in my calculator. And if you want, you can go ahead and put in the decimals right now. But I think it's a little easier if you keep them as natural logs until the very end, because otherwise you have a whole bunch of decimals running around, and that can make solving these difficult. So, okay, so what should we do now? What I would do now is move all the x's to one side and everything else to the other side. So I'm going to add 3 natural log of 5 on both sides, just to move that whole term over. And so when I do that, I get x ln of 5 equals 2x ln of 3 plus 3 ln of 5. So all I did there was just move the term over. Okay. Now I'm going to subtract to move all my x's. I can't just take off 2x because this is multiplying. I need to take off the entire term. So minus 2x ln 3, we move the whole thing over. Okay? So now we get x ln of 5 minus 2x ln of 3 equals 3 ln 5. Okay? And remember, that means 3 times the natural log of 5. All right, so what can we do next? Well, now what you want to do is, now that we have all of our x's on the left side, you can factor them out. Okay, you can factor out this x. And here's what that looks like. You factor out the x, and so you write x parenthesis ln of 5 minus 2 ln 3. I'm going to have to rewrite this problem somewhere else. So look what I did there. I factored out the x. If I did distributive property, we'd get this left side. So it's x times ln of 5 and 2x. So both of these 2x's got factored out, and the right side stays the same. Okay? And now we're one step away. I only have one x. Remember, this is just a number. ln 5 minus 2 ln 3, I could plug that in my calculator. So since it's just a number, and since it's multiplying by x, I just divide by the whole number. And I do that on both sides. Okay, which cancels, boop, boop. And we're left with the final answer of x equals 3 natural log of 5 divided by the natural log of 5 minus 2 natural log of 3. Another reason to keep the natural logs in the entire time instead of converting natural log of 5 into a decimal, natural log of 5 equals 1.609, is this is the exact answer. And if you plug in decimals early, your answer gets further and further and further away from being correct the more algebra steps you have to do. So this is the exact answer, and you could plug this into your calculator and get some number, and which is also the answer, but it's better mathematically if you can leave it in this kind of form. All right, let's go ahead and try to solve this one. I'm going to move it down here. So we have 4 to the 4x equals 5 to the 7x plus 6. So I'm going to solve that one in the next video. Let's solve this one right here, because this one's a little easier. So here I have to the x minus 2. So you want to do the logs, because when you take the log, you have to do it of the entire side of the equation. You want to simplify a little bit before you do that, if you can. It's kind of like simplifying before you take a square root. So let's try to isolate x as much as we can. Let's start by taking off 1. Okay? 2 times 2 to the x minus 2. Remember, we can't multiply these because of the x minus 2 up there. So I subtracted 1, subtract 1, and you get 66. Okay? So just subtracted 1. Now we should go ahead and divide by this 2, because that'll simplify a bit. 2 to the x minus 2 equals 33. Okay. Do you see how we've cleaned it up a lot now? And so now we can take the log. So we take the log, or the natural log, doesn't matter, log or natural log, of both sides. That allows us to bring the x minus 2 down. Like that. Almost done. We want to isolate this x, so let's go ahead and just divide by natural log of 2 to move it over. This is multiplying here, so we divide to cancel. So that means we have x minus 2 equals the natural log of 33 divided by the natural log of 2. And now you're just one step away. Just add 2, add 2. And that's it. So we get a final answer of x is equal to the natural log of 33 divided by the natural log of 2 plus 2. And that's the exact answer. If you plugged this into the equation, that's the exact answer to get 67. If you want to plug it into your calculator to get a number, that's fine, but just know that that will be an approximation. So hopefully you're kind of getting the hang of these. This one right here, I would say, is a calculus level difficulty problem. So hopefully all of these steps made sense to you. I'll see you in the next video where we solve this problem. See you in part 2.